Hello hams and hamsby, Lucas WMBTR here. Today we're taking a look at the all-in-one board. So I've talked about this in the channel before. I'm one of the people that sells this. You can get this on bigtimeradio.us, our website. But today we're actually going to make an interface for the Icom IC-706MKIIG. This is a great candidate for the all-in-one board because it does not have a built-in USB interface. So you have to use something like a DigiRig or a SignalLink, but this is a great way to do that cheaply at half the cost. So let's head into the shop and we're gonna work on making a cable right now. All right, so the all-in-one board is a sound card interface and control interface for a radio. That sounds fancy, but what exactly does that mean? Well, with a digital interface on an HF radio, whether it's built in or whether you're adding on one with something like a SignalLink or a DigiRig, or in our case, the all-in-one board, you can do a lot of digital modes. There's a bunch of them out there, things like FT8, there is JS8 call, there is slow scan television, there's VARA AC, there's Feldhell, APRS, WinLink, which is email over HF, really cool. And then there's whole applications like FLDigi, which can do from Morse code to PSK to Livia. You name it, it can do most of the modes. You can send files, you can have long-distance relayed communications, you can do a bunch of different things. They can work with the VHF, UHF radios, they can work with HF radios. Basically, the idea is if it has PTT, ground, audio in, and audio out, it'll work with the all-in-one board. And as a bonus, if you do serial, it'll also work with that too. But how do you actually make the all-in-one board work with your radio? How do you know what type of wire or adapter to make? Well, we do have these standard pinouts here, these easy solder pads, but in order to know what to actually connect it to, where you should look is usually a manual or a service manual. Most ham radios actually tell you exactly what each pinout does. So if we go over to Google here, we can search IC-706MKIIG manual, and let's just pull it up. Most manuals are available just online, which is a lot easier than the paper ones. Paper ones are great, especially if you're out in the field, out in the mountain, you are doing soda or something like that, you don't necessarily have access to the internet. This will work great to have a paper one, but in general, these are great because you can actually search. Like if I want to search for, what should I search for? Like power output or something like that, or well, I can just, power cable, like you can find it in here, and this makes it a lot easier. What we're going to do is we're going to scroll down here. In this particular manual, the pinout, in most manuals, it's pretty close to the top, or it's pretty close to the bottom, one or the other. We're going to scroll down here. We can see where all these different connection points are. The one we're interested here is the accessory socket right here. Enables connection to an external equipment such as a TNC. The AIOB could be considered TNC. A true TNC would actually have a computer built into it as well. The all-in-one board, well, technically does have a computer built into it, but you're connecting it to your computer to do all of the hard work. So your computer and the all-in-one board combined are a TNC, but that's semantics anyways. We've got the accessory socket, so that's a good starting point here. And this accessory socket is what we want the pinout for. So in our case, if we scroll down here just below where it says that the accessory jack is there, we can see this pinout here. We've got pins 11 and 12 are going to be the input and the output. So this is going to be the microphone input. It's going to go to our mic, and this is the output, which is going to go to our speaker. On the AIOB, this is kind of like a speaker output, but it's a bit more precise. We've got a shared ground for that, and also the PTT, which is going to be pins 3. This is goes to ground when transmitting, and when grounded transmits, that's what we care about here. When we ground it, when we trigger the push talk, it's going to transmit on HF at 50 megahertz. And then also pin 7. This will transmit on VHF. Now don't worry, if you are set to HF, it will not transmit on VHF at the same time. It's whatever, we're using both of these at the same time, so that way whatever mode you're set to, it'll transmit on. Otherwise, you'd have to change the pin out. But if we just connect both of those together for the all-in-one board, that works fine. Now, another great resource, ironically, is our competitor, the DigiRig forums. And in fact, the DigiRig cable here for the 706 Mark II, which allows you to interface with the DigiRig. If you already have one, this might be a great choice if you already have a DigiRig. They often have the pinout on it. And we can see on here where the DigiRig has AF out, which is the audio out, and AF in, audio in. Those go over to pins 11 and 12 right here. So that's a great starting point. And then PTT, again, goes to 7 and 3. Same thing where they're bridging them together, so you can use it for either HF or VHF. And then pin 2 is that shared ground. So that's a great resource there for how to get started. It's just another thing you can check to see if they have one on there. Now that we figured out that, we can highlight the ones that we want, and we could print that out. That's a great place to start. Now, of course, for your radio, it's going to be different if you don't have an IC-706 Mark II. The pins, what type of connector you're using, are going to be different. The purpose of this video is not to be a step-by-step guide unless you happen to have a 706 Mark II, but it is actually just as a kind of a guide to get a hang of what you're going to do for your radio. You're going to figure out what the pinout is, you're going to figure out what the connector is. We're going to talk about in a minute here how to figure out which pins are which on a cable if you get one, and then we're going to talk about soldering it all together and testing it as well. So this is a 13-DIN male connector right here. They're fine connectors, but they're kind of a pain in the butt to solder, to get the pins on there and then to close it up and to trust the connection. So a hack that I recommend is that you can go on Amazon or wherever and you can buy pre-made cables and cut it and then just strip the wires. Right now I'm using full cutters here, but you could use a pair of scissors, honestly. These are not super thick or tough cables. And I'm just going to cut it. Actually, in this one, I'm not going to cut it too far in because I plan on putting the board itself kind of on the radio. So I'm just going to cut this here. You can see it's somewhat similar to like a Cat 5, how it has all the different colored cables in there. So I'm just going to try and cut into this without cutting into the wires inside. Err on the side of too thin, because you can see that as I'm stretching this, see how it's exposing the kind of underlaying layer right there? Over here it's fully split open, and if I keep on pulling, it splits it more and more. And then I can take my knife and kind of just barely tap it, and it opens up more. Now this stuff is shielded too, which gives you a bit more wiggle room as far as how far you can cut. And that's also nice because for radio, shielding is really good because it's going to block RF from interfering with it quite as much. A little bit more here to get through. All right. Now we're just going to pull this back. Okay, so there's a braided shield on the outside. And as we go in, we've got a foil shield. And note that this will be connected to your radio's chassis ground just by the way the connector works. That is connected with this outside shield here. And we've got, some of these are wrapped and some are not wrapped. So I've made this little pinout sheet here. You can see it kind of works in a pretty standard layout. And this is from the perspective of the socket, not from the cable. So keep that in mind as you're looking at it. So when we're looking at the cable, that is going to be the perspective as you're going in like this. So if you look at it like this, it's going to be reversed, where this side over here is going to be 1 through 4, 5 through 8, 9 through 12, and then 13 at the top. So just reverse it. In fact, I'm going to do that now because it's the cable I'm testing out. So we've got pin 1 on the right, 4 on the left, 5, 8, 9, 12, and then 13 at the top. So that's if you're looking towards the barrel of the cable. Now ideally, we know which pins we need, right? And in this case we do. We know we need pins 2, 3, 7, 11, and 12 in order to make this circuit. But if we could connect these easily and then test the wires one at a time to figure out which one's which, that would be ideal. But that's actually really difficult because the wires are easier to get a stable, constant connection to than these pins are. It's hard to like hold this somewhere while you're then tapping the other ones. Strip some of it back. And since this helping hand set is metal, but you can also just use like a clothespin or a chip clip, I'm going to pinch the metal of the connector, and then I'm going to, on the other end, pinch my probe. And now if I touch this, you can see it's a constant connection. So now I can take that, and assuming I don't rip it out of the pin like I did just now, because I'm trying to get this on camera at the same time, let's peel this back. Actually, is there 2 wires in there? Ha. Yeah, it looks like they glued it, so I'm going to take this and just kind of... You can see, if you look at it closely, that you see the thin wire is wrapped around right here where it goes through. You can kind of see it poking out right there. Kind of like a Twix bar vein. That's going to have much thinner much thinner jacket than the other one's going to have. So if you're going to cut into it, I recommend doing it in the thicker one. So I'm just going to kind of slice it here. It's never this hard, but of course once I film it, it's going to be that hard. All right, here we go. We've got a thick green wire, which is not to be confused with our thin green wire right here. And we've got this clear one that was in there with it. So let's stick this back some. This onto right here. And now we're going to check these pins one at a time with the other end of our multimeter here on continuity mode. So again, if I touch this, it beeps, so we'll know we have continuity. First, let me check the shield. It's not that. Oh, did I just get it in the first try? I did. So this is pin 4. That was quite lucky. So that one's 4. So now what I'll do is I'll just write that down. Then pin 4 is, I'll just do THK green. Now, why am I checking these if this is a standard color scheme, right? Because I don't trust these cable makers. Especially the cheap Amazon ones, you don't really know. But this is how you can, I'm just teaching you this as well because this is how you can figure out the pin out to any cable. If you're using it for a DIY project, is you can cut it and you can just test these probes one at a time. So let's move to this clear one. Nothing in the first row. This one? Yep, this one is pin 8.
5977 Charles on a
quiet dispatch. All right, so that's the clear one. So I want to verify here. Is there a clear one in every one of these? Because in that case, just calling it clear is not particularly helpful. And yeah, so you can see here, there's a blue one and then there's another green, clear one. So we'll call this one clear green. Yeah, I just looked at some pinouts online and a lot of them are different and none of them have green being pin 4 and 8 being the clear one that's with that. So this is why we have to do this. We have to figure out which one's which. It's because we don't know which one's which. You can look at some guide online, but who knows how accurate that is with this manufacturer. All right, let's try this. My guess is it's going to be one of these bottom ones. Oh, yep. Thick blue is pin 3, which means I'm guessing that 7 right up above it is going to be the clear one. Yep. And pin 3 is one that we need, as is 7, so that's useful. 4 and 8 we're not going to end up using, but we have them mapped out for any other projects that we might use this same cable for, or in this case, the other half of this cable that we're not using here. And I'm going to trim some of this back too, just to get it out of my way. If the trend is continuing, this one is likely going to be, what is it, pin 2, I believe. Right, it's going to be this one, because we've had 4, and we've had 3, so this one should be 2. Let's see. Yep.
A few moments later.
So then purple is going to be 5, right? So we've gotten everything else. Oh, I didn't write down 13, because whatever reason. Is it 13? Nope. So it's going to be 5? Yep. That one's our 5. All right, so we need our pins 2. Pin 2 is going to be ground. Pin 3 and 7 are going to be PTT. Pins 11 and 12. 11 is going to be the AF in, and it's going to be AF out. So into the radio and out. So this is going to be mic. This is going to be speaker. So now what we want to do is cut back anything we're not using. So the ones that we need out of here are 2, 3, 7, 11, and 12. So that means that all of these ones we're going to cut. The green one I do not need, so we're going to cut this one. Yellow one I don't need. The clear one that was with the green, I don't need that. Cut that. So now the ones that we've cut, what we can do to make sure they're not going to have, a curly Q just happen to get in there and touch something and short something, which could fry your radio, so take that seriously. So we're going to take some, a couple ways you can do this. You can wrap it with electrical tape, or if you have some really small, thin heat shrink, you can use that too. That's what I'm going to use. I got this thin stuff. You can do each wire individually, but you can also stick a few together as long as they're not the exact same length. Use a lighter too for most of this stuff. Sorry, this was off the camera, but I put 3 wires that I'm not using in here. And I'm just gonna pinch the end to close it. And see how that's a nice, it's wrapped around these wires, so there's no exposed copper. And then it's pinched right there, so nothing can poke down there. And I also want to do that with anything else that we aren't going to be using. And I think at this point we're ready for us to prepare our all-in-one board. Alright, so we got the all-in-one board here. And as you can see, it is labeled from the perspective of the radio. So PTT1, PTT2, that's for dual PTT. That's not for the 2 PTT sources here. That's if your radio has like a dual PTT. For some HTs have that, or one can go to Morse code as well if you'd like. But PTT is going to go to our 2 PTT pins here. Ground is going to be the shared ground. Sometimes you'll have an audio ground in, audio ground out, and then the PTT ground. In this case, the connector already brings all of those together to pin, which one is it? 2, right here. Radio mic, that's going to go to the AF in. RRX and RTX, those are for serial. And this radio, this Icom radio uses something called CIV. It's an Icom standard for serial communication. And then speaker is going to be AF out. You could also hook this up to a speaker out jack. And then again, the speaker ground would go to here. But in this case, this is going to go to the AF out, and then it uses that shared ground there. Excuse my chicken scratch handwriting, but we've got ground, we've got PTT across these 2, we've got mic, and we've got speaker. And note that for radios where you do have more than one source of ground, the ground pad is also exposed on the bottom, right there. So you have a second pad, so you can solder more connections on there if you need to. It depends on what you're using for cable. So the helping hands come in handy here, but they're not necessarily needed. I'm going to grip onto it with both sides here. Once again, this is also not needed. I've got some flux here that makes soldering a little bit easier. So if you've got it, you can kind of just dab the pads with some flux gel, or squirt it with some flux fluid. And what flux does is it cleans, as it heats up, it cleans and evaporates, and it just makes it easier for solder to make a good connection. Sometimes it's more important on the wire than the pads. The pads are usually pretty easier, or are usually pretty easy to solder on there. Let's grab our ground source first. And like I said, in this radio's case, it is a shared ground already, instead of having to solder all these grounds together. So that makes things easier. So our ground is going to be 2, which is thick red. We've already got a good amount exposed here. Let's just twist this wire up nicely. And you can see these little holes on the all-in-one board there. And that is so that you can stick this through, so that you can ensure that you get a good connection. And it's okay if one of the little curly cues come out. You don't want it all the way down. You'll see how I'm doing it here. It's pushed in there. I don't know how well you can even see it. It's in there, but it's not all the way in. And I'm going to reach behind and just fold it back. And see how it's folded back there? That's going to hold it in place while we solder. I'm going to pull it back a little bit more. And it's going to stay there because it's pushed through there. That makes it way easier to solder. That's why I designed those holes on there, so that that's a little bit easier. Take our solder. In this case, I'm using lead-free solder, so you will not see a nice glossy finish, but it doesn't necessarily mean the connection is bad. Grab my soldering iron. Now, one thing to keep in mind before we solder here, if you're going to do heat shrink, like for example, if you wanted to do heat shrink along here, you want to put that on now before we start soldering. Ideally before we put this guy in too, but that's quite all right. I'm not going to do that. I might just do some heat shrink over the whole thing at the end. All right, so this is heating up nicely. Put some pressure on there. You likely know how to solder if you're getting one of these, but these are easy solder pads, so even if you're not an expert, it's designed to be really simple and easy. And even if the solder isn't perfect, because we have it pushed through there, that hole, the inside of the hole in here, is also lined with the metal that is a connection. So as long as it's held in place, it's going to be a good electrical connection. So pin 2, which is red, the thick red, is now attached to ground. Now let's grab the PTT pins, which are 3 and 7, which is going to be thick blue and the clear blue. All right, I've got some through. I'm folding it back. I believe some kind of crumpled up there at the bottom. That's okay, because it's going to be held down by the solder once we have the solder on there. I got some of the plastic. Right, kind of loosened itself. So another good use for flux is if you dip the wire in flux, it makes it kind of sticky, kind of like if you were to lick it, and then it would be more likely to stay together when you tie it. There we go. That's going through. I'm just going to fold it back. Sometimes it's helpful to get a little dab on the iron right away, because that'll help it make a good connection. To then heat up the rest of it, and then you can put the rest of the solder on a minute later. So I cut the white wire back at one point because I wasn't paying attention to which one was next on my list. The white is the microphone, and that does not want to reach. What I'm actually going to do is take some of our cut yellow wire here and use some of that. I'm going to extend it. There we go. See how it's twisted on there? That's definitely not a secure connection, but we're going to solder it so it becomes a secure connection. Just got some wire sticking out at the end. That's perfect. That should do the trick there. All right. Just push it so it's nice and flat on there. Heat it on up. There we go. So we've got PTT, we've got ground. Come on, focus on me. There we go. Got ground, mic, and speaker. We're leaving the RX and TX pads open. Now what we can do as well is cut these back a bit. Now what I've got here is some thick heat shrink. What I want to do is heat shrink over this to make a good seal over that. I'm first going to wrap some electrical tape over this section here, so it's not going to hit any of the pads under here and cause any issues shorting stuff out. Just using some Scotch 700, but any old electrical tape will totally do. Let's just wrap that right around here. Got that wrapped. Now I'm going to fold this as best I can, trying not to strain the cables too much. Like this mic one, or sorry, the speaker one is the furthest away from the source, so I don't want to strain that too much. Got this heat shrink here. This is 3:1 marine heat shrink. Marine means that it's thick and it has this kind of, see how it's glossy inside? That's going to melt and make a nice good seal. So yeah, fold it in a way where it's nice and compact, but there's not a ton of strain on anything. And we're just going to go over it with this. You know the drill by now with the heat shrink, right? And our LEDs are right up here in the corner. Not really an easy way for me to have them very exposed, but we'll do what we can here.
A few moments later.
It's not perfect, it's not going to keep it waterproof or anything, but ideally what it will do is take some of the strain off of those connection points and give us a nice little cable here. And there we have it. We've got our all-in-one board cable ready to go. All right, so we've got our cable right here that we've made. We've got our 706 Mark II. So let's go ahead and plug it right into the back right there. All right, I've got my laptop. You might recognize this guy. This is the Evolve 3, which is a interesting little laptop, not particularly powerful, but what makes this laptop unique is that it is powered off of 12 volts, which makes it great for powering off of a ham system. If you're powering a radio, you can power this laptop as well. We're going to power on our laptop. Let's get our 706 Mark II wired up for action as well. All right. So we're going to take our USB-C cable here, hook it up to our AIOC, and I do see the lights blinking on that. It's kind of hard to see because of the heat shrink around it, but you can kind of make it through. Yeah, I heard it connect. The good news is the drivers work great on Windows 10 and 11. It just kind of plug and play works, but you do want to have an internet connection in order for it to to work the first time. So we've got Wi-Fi running, and I can see that it's COM7. And then for the audio device, currently when you first plug in a new audio device into Windows, it's going to, by default, switch to that, as if you plugged in headphones or a pair of speakers. You're going to want to make sure you switch back to your normal stuff, otherwise any sound, notification sounds, button presses, if you have anything that has button press sounds, if you start playing a video, it's going to go through your radio. You don't necessarily want that. So we're going to switch back to that. Now, let's open up WSJTX. Now, because I didn't set this up with the CIV modification, it does not have cat control to control the radio itself. So we're just going to go over to the FT8 frequency here, which of course is 14.074 upper sideband. Hear that glorious FT8. And we're going to go into our configurations here. Into, where is it? File settings, file and then settings. And let's go to, first I'm going to set my call. And which COM port was it? It is port 7. So we're going to set it to port 7. That's the one that I see come up in the device manager when I plug it in. And then the next part's pretty straightforward. It's audio. We're going to do the input is going to be the microphone, AIOC audio, and speakers. AIOC audio uses the same firmware as the all-in-one cable. It should be backwards compatible with any other updates. So it will show up as AIOC in the device, even though it's an all-in-one board. So we've got our PTT method set to DTR on COM7. We've got our audio set to AIOC and AIOC. Let's hit OK on that. We should start seeing audio coming in. Oops, I must have bumped this and changed the frequency, so let's change this. All right. Yep, and I'm seeing on there, I'm starting to see the FT8 come through on there. So now that you've got that set up, we're going to start decoding things. And I'm starting to see messages popping up. There we go, it's working. It's working in the receive already, so now we're just going to transmit, send out our call. So I set my grid square, we've got tuned in here. We're decoding tons of stuff. We're going to enable TX here. And we're going to call CQ. It's already calling it. See, I've got about 2 SWR on this antenna, that's all right. And we'll just keep on calling it and see if someone grabs us. But either way, we're going to check on PSK Reporter and see which stations we reached afterwards. And we're going to see how far this got out on this all-in-one board. I'm also going to turn down my gain a bit here. I haven't tuned this to work with radio. With all interfaces, you're going to have to make sure that you're tuning it so the automatic gain control isn't working too hard. Here we go. I already see someone calling me, so I'm definitely getting out. This is 9A1AD. So that's definitely going to be DX to another country here. So let's see if we can get him in the logs. He's still calling me, so he didn't hear my last one. Let's try it again at a higher level. All right, higher power now. He's still calling me, so he heard that initial call, but he hasn't heard me calling back yet. Let's see. There we go. He heard me with a signal level of -9, so now I'm just giving the call back. So you can see it's working great. There we go, and I'm getting a 7.3 from him. He's saying goodbye. And that's it. I got him in the log. So that's the all-in-one board. Pretty simple to set up, pretty easy to use. Definitely a lot more affordable than, say, the DigiRig or the SignalLink. And for some great functionality here. So feel free to check it out on the website. It's bigtimeradio.us is our new store. Go to WMBTR.com. It'll still forward you to there when you hit shop. So either way, you'll still get to it. But thanks so much for watching 7.3. You can take a look if you want. Happy to have you over here. I want to grab my phone and see where that guy was I just reached. We do have DTR. Okay. All right. We're editing. We're recording. The cat's scratching at the door. But oh, hello, cats. How are you, sir? Do you want to say hi? You want to say hi?
This is Titus. This is my cat. Here's my hand radio cat. He's here to help.